Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have Iain Smith. He's the founder and MD of Fisher Smith. We're going to be talking about machine vision. He's been with Fisher Smith for 15 years, and he's a machine vision specialist and software engineer. So again, machine vision, I'm used to hearing stories of, is it a cat, is it not a cat type of thing, but I'm sure it goes way beyond that. So Iain, how you doing?
I'm very well, thanks, Richard. How are you?
Yeah, good. So you're not working on seeing if something's a cat or not. I'm sure you're doing much better things. What are you doing in the world of machine vision?
Well, it's certainly different. So really, my focus in machine vision is on the industrial side of things. So very rarely in industrial settings are we looking for cats and dogs. Now, maybe apples and pears if you're trying to sort fruit out in a sort of a agricultural industrial environment. But more than likely, we're looking at things that are in a manufactured environment. Things that are being made on production lines, widgets, bits of plastic, medical devices, consumable products, automotive products, consumer tech, almost anything that is mass manufactured, there could be an application for machine vision in that area.
So what are some examples? Like, what do people need to use machine vision to figure out, is a part shaped properly, or like what are some of the applications?
Exactly. So the most common ones we see are for a quality control type of application. So this is where you're making thousands, hundreds of thousands, millions of the same objects. So this could be Coke bottle caps. It could be some pharmaceutical drug or pill, something where you need every single one to check, is it complete? Has it been made correctly? Has it got the right logo on it, or the right text or information? Is it the right shape or size? So automotive's a big area where quality is a driving force, because the car manufacturers want to make sure that every car they produce is right, it's right first time, and it's super reliable. And you do that by making sure all the individual components that make up that car are to the specification they've been designed. So even down to the very basics of a nut or a screw, if that screw gets to the production line and the guy's doing the assembly and he goes to tighten it into place and it doesn't have a thread on it, or it's the wrong length, or it's the wrong size, that's now downtime. So to have all those products checked ahead of that, so that they know what they're getting is going to be right first time, every time. And often a way of doing that is to use machine vision, use camera technology to achieve that.
Well, it seems like, I don't know, once you know what an object's supposed to look like, I mean, is it difficult to, we can't, like, I don't know, it seems like you don't have to tolerate much deviation, but maybe, I don't know, if you have a camera looking at a conveyor belt and you have the same object, but maybe it's in different orientations, maybe that makes it harder. Like, what makes this difficult to do?
So a number of things. So one is, as you say, presentation of the parts. So if the parts are coming jumbled up, they're all on top of each other, overlapping, and you're trying to look for, say, a surface scratch or a blemish or a defect. If you can't see the surface that you're trying to check, you can't validate it. So some aspect of it, we need the automation, the general automation around, to make sure that the products are presented reliably to the camera, so that we can always see the areas we need to see. And depending on what the product is, that could be something really obvious. You think, well, why would you need a camera to look for that? Some things might be so small or so subtle or so minute that actually a human is really unreliable about detecting such a small defect wherever it may occur. So we see some things where the drive to use machine vision is because even though a fault is fairly obvious, if you put a human inspecting it, they'll catch it most of the time, but the time they switch off, or they didn't have their morning coffee, or they're talking to their friend and they let one go past, oh, that didn't matter, I didn't catch that one quite right, then a defect gets through, and okay, the product may fail in operation, or it may just look bad. But we're talking about, big companies' brand images, that they don't want to see their logo mispresented. They don't want to see a big dark mark on the side of a bottle or a beverage, because people look, oh, there's something in there, it's dirty. Well, it might not be. It's just a bit of an anomaly in the packaging material. But the consumer looks at that and thinks, well, I'm not going to buy that one because it looks like it's got something inside of it. So that can be a reason to sort of utilize vision as a technology. And what makes it hard is when you've got 10 bottles a second whizzing along a production line being filled with whatever your favorite drink is, then a human just can't keep up with that line rate, that speed. Whereas a camera can take an image, inspect that image, and give a result back for the automation to knock it into a reject chute or away from the good production without interrupting the speed of the line. So high speed manufacturing, is one of the key areas, because the vision is fast. You can take you can acquire an image and inspect it in less than a tenth of a second, sometimes even faster, depending on your processing. So it's a very different environment to is it a cat or is it a dog?
Yeah, it's totally different. But okay, I see some of the challenges. You know what I'm envisioning is, pun intended, I don't know, I guess I keep envisioning, if a part comes down on an assembly line, let's say, wouldn't you have to have something that turns the object, at least so you could see all the faces or a few sides to get a much better idea of defects? Like, looking at it one way, I can't see how you'd get enough information, especially about internal features or stuff on the backside, let's say.
Yeah, so some of that is absolutely true. And whereas some of it, these machines are put together with pragmatic choices being made about what gets inspected, what fault types are we likely to see. We know what the manufacturing process for these parts is. Are we likely to get a fault in the inside? Maybe not. So, for instance, with plastics, where you've got a mold that you're injecting hot plastic into and it's filling that mold, there are certain areas of that where it's almost impossible for the plastic not to go in that area, because it's got to go through that area to get to the other bits of the mold. So then you tend to focus on the areas where they're at the extremity, where if not enough plastic goes into that mold, it won't quite reach that little bit that's sticking out at the end. So let's check just for that bit sticking out of the end, because that will tell us if that's not there, then the whole part's bad. We don't need to look further up the product. We might not need to look inside of it on the other side to check on that defect. So yeah, some of it you physically can't see. Some of it you might have to get around that by having multiple cameras looking at all the sides as it goes past. Sometimes you need to pick that part up with a robot or some sort of handling device and actually move it around and manipulate it so the camera can get lots of views. So
what if you send something through one camera, you flip it, send it through another camera, flip it again, another camera, and do it that way, so you can keep high speed and throughput, but get, let's say at least 4 looks at it.
Yeah, absolutely. Yeah, that's one of the techniques we often use. It tends to just come down to every time you say flip that object, it takes some handling time. So have you got does your process allow you to do that? And is there budget to have a camera at each one of those inspections, or does the customer make a choice on, I'm going to focus on this area only and accept that we might get some defects on these other ones, but they're a lower risk factor or whatever. So
and then if there's like 10 steps in making something, do you put the camera at each step, or only at the end, or critical steps? So
again, there's no one answer to that. So sometimes we put a camera at every single step, and that way ensures that every step that you take in that process, you're not adding value to a product that's already wrong. So if you found a defect early on in the process, you stop it there, address it, fix it before it goes on to the next process. So you're not making the problem worse. Whereas some processes, it doesn't make sense to do that. So you get the final assembly and you check in multiple places all at the same time, or in a sequence of checks, to make sure that all the parts are there, and then quarantine or reject the ones that aren't quite correct.
And in the vision itself, do you look with visible light, X-ray, infrared, et cetera? I guess you can combine all those too. Sound.
Yeah, so the majority of the products we're using are visible light, but we do infrared, ultraviolet, which are the two ends of the spectrum where the light starts to go invisible. Generally, we don't go to X-ray. There are some specialist companies that do go to those technologies. There are some other allied technologies where similar sort of images get generated with other techniques, but the majority of what we do is with visible light, and that can be color. So we use a white light, we generate a color image as you sort of expect, really, but sometimes we don't need the color information. If we're just checking a dimension on a screw or a bolt, we don't need to know what color of silver that bolt is. So we have a light behind it, we have a camera in front of it, we only need a black and white image. That's all the information we need. So that simplifies the data, makes the inspection simpler, faster, more robust. So we don't complicate it by adding color into it. The same as we can also generate 3D images if you're looking to work out the volume of something. So is this loaf of bread the right size? Is this, how do I chop this bit of cheese up into slices of the right, so each one's the same weight or a particular weight? And then you can generate 3D information from a camera to get height, width, depth, volume, and find features in 3D. So you can even use that sort of technique to generate data that robots cut, so they can accurately pick up a component from a particular place, regardless of where it's shown in front of the robot. So you can automate handling as well.
I was going to joke with you and say, see, it's a lot more complicated than just saying, is it a cat? That's what you would say to me.
Well, in some respects, actually, is it just a cat is one of the hardest things to check, because how do you define a cat? Well, what colour is a cat? Could be all sorts of different colour. How big is it? Is it moving? Is it still? Is it sitting? Is it standing? So many different parameters to try and define what a cat is. Is a cat a tiger? Is it a domestic cat? Where do you draw the line? So in some respects, that aspect of it is quite difficult, and often quite a different technology, which we'll maybe talk about in a minute. Whereas often in the industrial, we are looking for a specific object with defined characteristics, and that allows you to set very known parameters and known limits on those items to ensure they're consistent.
But as we were saying, I could see why it's so much more complicated than when I first thought. I appreciate it more now.
It's one of these things where, as consumer technology is advancing so fast, we're now really used to having a phone in our pocket which has an amazing camera on it that can detect faces, remove movement from videos, or stop the camera looking like it's shaking. It can adjust for brightness, take images in dark conditions. You upload it to one of the big cloud providers and they'll tell you whether there's a cat or a dog or a person in there. You start tagging photos, it starts to recognize that's Ian, that's Richard, that's, and this is starting to become normal. But this is a very different technology, and a different things drive that technology to what we're using. And we're starting to see this become more and more of an expectation gap in our industry, where we're saying, well, we've got these very robust, reliable tools to 100% check your product at 10 parts per second, whizzing down this production line, but we can't tell whether it's a cat or a dog with that technology. And people are, almost expect that. Or why can't we have a 50 megapixel camera? I've got one of those at home. It only cost me not very much money to have that, or my cameras.
Well, it's
my
not just the
phone.
camera; it's the software, the interpretation, which is the big deal.
Yeah, and a lot of that we're getting used to as consumers is based on uploading the data to the cloud in some way, and some supercomputer or series of computers in the background is doing that classification, working out cat, dog, human, doing some of that correction. Or some of it is done on device, but it's quite specific to that particular task, and there's no particular quality requirement on it. If your phone processes that photo and to enhance your face, and you don't like the look of it, you delete it and take another one. We don't have that luxury in automated inspection, because you need to check every single product the same time, the same way, and guarantee a result every time to ensure that you've got a consistent, reliable, validated or validatable process that you can rely on to get the product to the customer correctly.
Well, I'm
every
also
time.
hearing a lot of, there's a lot of trade-offs. Again, if I was making something, I'd love a system with cameras that look at it 4 different ways at every step of the process. But, there's trade-offs to speed, et cetera, et cetera, et cetera. What's really useful to know, what's not. So
yeah, and one of the big trade-offs that we see is that often the projects we're working on, we're looking at, this company is making this particular product, and they're making, that might be a dedicated production line that's going to make that product for the next 10 years. They only really need one production line because they only need 1 million units a year, and that's a fairly consistent demand. They might make a second one, but that might come in 2 or 3 years' time. So we solve a problem to inspect that customer's product, but it's completely different to the ones we did last month, the month before, the month before that. So we're deploying standard or standardized systems to try and address that. We don't have the luxury of a Google or an Amazon or something getting all this data from millions of users, uploading it all, training a big AI to...
Yeah, but are you keeping the data though? I mean, if I would think that you should. If you have an algorithm that, I don't know, it's really good at figuring out complex shapes, or one that's better with, I don't know, black objects or shiny objects. I mean, I would think that you can selectively layer in all those machine vision components and make your system smarter and smarter, because you're getting millions of data points if you capture your data and don't reveal it as anonymize it somehow.
Yes, technically that's possible. It doesn't tend to happen, I guess, because the design cycle and deployment cycle of these systems is to a deadline, to a defined point, and once it gets to the point where we've met the criteria, then generally that's it. Customers ask us to inspect their product to this quality criteria, and so long as we can reliably do that and it continues to do that, that's their desire, their requirement met. What they should be doing, and what is recording that data, using that data to learn about their process, and then to feed that back into their process to say, well, when we see the camera finding this type of problem or rejecting in this way, that's because something further up the production line has happened.
Well, why don't you bake in why don't you have a maintenance contract for your system? And then part of that is they have to allow you to collect the data. They can't use it in a way that displays whose widget it is that you're looking at. But if you did that, that would give you a good excuse to go back in there and monitor them and improve your systems and get trillions of data points,
Yeah. Some customers we have do go down that route, are happy for that, and some don't particularly value that data. So long as their product isn't going out wrong, that's all they care about. If they're not getting fines from their customer or dissatisfied phone calls, then that's the limit of what they care. If they're making a few more scrap products, depends how valuable the product is, they might be happy with that and just accept it or rework it or throw it away and accept that whatever goes out that's good that's all they need to know. Whereas other customers do take that data either themselves internally, or come back to us and say, analyze this, give us the feedback, help us improve, help us continue to improve the process. And often what we find is that one of the great benefits and big limitations of the camera technologies is that they are totally objective, and certainly with or say standard vision techniques, you're working to a set of rules. So if the product conforms to that rule, to those set of rules, and it passes, it's accepted, it moves on. If it doesn't and it's rejected and kicked out, what we often get with customers is say, well, we would accept that. And then you've got this, well, it's different from what it was before, but now the customer's saying it's acceptable. So how do we throw it back and say to the customer, well, it's different in this way, therefore it's not the same as before, except that it's a bad product now? Or what usually happens is the customer says, adjust your system to now accept this variation, which we've perhaps never seen before.
Well, I mean, you know what's cool is if I'm assembling something and I'm getting parts from suppliers, I mean, you can vet my suppliers. Like, you know, we know that this, whatever circuit board we get from so-and-so has worked in the past, but we want to use your machine vision thing to see if that changes. All of a sudden, the parts we're getting from them are now off, you know, a millimeter in this direction or something. I mean, you could also do that. You could help with like supply chain issues too, you know, like
yeah. And sometimes that's done at the end of the process by checking what's coming in is right, and then they can throw it back to that supplier and say, what you've supplied us is wrong. And other times the companies will push that out to the suppliers and say, in order for you to supply us, you need to guarantee us that these products are being automatically checked and validated, so we make sure that they are coming in right, and we don't have to check them when they arrive at our factory.
Do you find that in some cases your system's so good it finds issues that the manufacturer never even thought of, or they're like, that's weird?
Absolutely, and that comes in two flavors really. One that I've just mentioned is where the product has varied, but to the customer it's acceptable variation. It might be a slightly different variation of the color. It's still about the right color, but it's changed enough that it's outside the parameters that the camera has been set to detect. And then on the other hand, we had one particular customer, and they made products in a big tray. There was 900 products in a tray, and the tray is only, say, a foot square. 900 of these really tiny little products sitting in pockets on this tray, and we put a vision system on there, and they kept ringing us up saying it's rejecting every single product on a tray, and we've shown it to our operators who used to do this inspection, and they can't see anything wrong with it. Come in and fix your camera system. And this went on occasionally for a number of months, and we rechecked the system, validated it onto known good products and some known failure products, checked that it correctly found them, not a problem. In the end, we worked out that if we put one of the products from the bad tray and we introduced it to a known good tray, then the operators would pick up that one bad product every single time. And the reason the vision was rejecting the whole tray of all 900 products, every single one, was that they were all wrong. But when you showed it to a human, they were saying, these are all the same. I can't see any that are different. So therefore, I think they're all okay. I'm expecting the majority to be correct. And they're all the same.
Okay.
So they're all correct, and putting them to one side. But if you took one from that tray that the vision had rejected and put it into an otherwise good one, every single one of the humans would go, oh, there's the bad one. Oh, that's that one. But you put it into a tray where they're all the same and they're all this uniformly bad. They couldn't. The human mind just said, well, nothing's different. It's fine then. So that was a real eye opener for them. You know, it was great for us and great for the sort of customer champions that were looking after this machine, to say, actually, this inspection is working really, really well, and it's doing this. And if we hadn't have had this, all of these products would have gone through and got to the customer.
You know, what's interesting too is not only can you see if something's good or bad, but you could probably see error propagation. If an error magnifies over time, you know, through a lot, or if a certain percentage of a lot is bad, or if the beginning is bad, then the middle is fine, or just the end is bad. I mean, there's a lot more. I don't know. I'm just getting interested in it as I talk to you. There's just a lot of nuance and variation you could find out and figure out.
There is, and this is a big driver for you may have heard the phrase industry 4.0, a sort of idea that in manufacturing, all the technologies that are involved can communicate with each other. They can share data, they can all record data and centralize that, so that these, exactly as you say, can we see a trend with this particular? So the camera system is saying this, but maybe a motor or a temperature sensor is saying this, and you've got all these different data points. Can you put them together, join the dots, and gain some insight into your process by seeing, yeah, this thing's happening as the temperature starts to rise, the camera rejects start to go up. Okay, let's control the temperature, then we make better products.
It's like this restaurant I go to, and on the weekends their food's not nearly as good, and I know it's the cook, but they're like, no, it's not that, and I'm like, please, it is. My food eating vision tells me it's
yeah.
Huh. Well, that's really cool. So what kind of companies do you guys tend to work with, and who are you looking to attract in the future and now?
So we focus on this, say, niche of machine vision. So often our direct customers are the type of companies that are building automation machines, production manufacturing machines. So they're putting together robots and conveyor belts and handling systems and all sorts of different mechanical and electronic components together to take maybe raw material or subcomponents and turn them into the end product. So they tend to be our customer base. Vision is something that gets used increasingly frequently, but is still seen as a bit of a specialist area. So a lot of those companies don't have in-house skill and look to outsource that to companies like ours. Occasionally we have a direct relationship with the actual end users, the manufacturers. So your car maker who's actually producing the end products, and they want to deal directly with us. So those are the sort of people we tend to work with. And then on the other side, we've got quite a big global supply chain of companies that make the equipment that we're often putting together, choosing the right components from the right manufacturer to create a really good system. So there are a number of industrial camera manufacturers, companies that make precision lenses for the cameras. We do almost everything with LED lighting, which allows us to illuminate our object and the scene we're trying to work with really consistently, really evenly, and often very brightly as well. And with the LED technology, control that. We can turn it on and off with inspection if we want to flash that light for just the tiny fraction of a second the camera needs. We can do that to make it super bright, but not overwhelming to the environment. So yeah, we've got a whole network of suppliers who produce really high quality components that configure together to really work.
So what's the future of your work look like in the next few years? What kind of innovations are coming?
So one of the big ones, and we've sort of already skirted around this really, is deep learning. I'd say it's a narrow area of AI. So we're looking at deploying deep learning systems now where it's focused on industrial inspection. So it's not so good at your dog and your cat, but if you're looking to find scratches on a medical screw, you can train the deep learning to find defects where there's apparently very little contrast, very uneven, there's variations in the product, there's things that you can't easily define by rules, which then takes it away from the stuff that we'd normally do with the standard camera technologies. And this deep learning starts to really be very, very powerful. It's a slightly different mindset, different way of working, and often because it's an industrial process and we need to guarantee the speed and accuracy that we're working at, we can't rely on taking an image of the camera, uploading it to the cloud, letting the processing happen in the cloud, decide whether it's good or bad, and then send the result back, because there's a pretty good chance that your internet connection is not good enough to do that with a small enough latency to get you the result back by the time your widget has got to the point where you've got to accept it or reject it on the production. So a lot of this deep learning is being done locally on a high spec computer, and even now to the point where one of our major suppliers, an American company called Cognex Corporation, have just released a product where this deep learning can now be run on what we'd say is embedded hardware. So not a big industrial Windows computer, but a small footprint device that runs its own operating system purely to do machine vision inspection, and that now can run the deep learning algorithm and do the detection, this deep learning detection at high speed locally on the production line. And it's in a package that's easy for us to deploy, robust in the industrial environment, and could be a real game changer, I think, for the industry. Okay,
well, very good. Iain, so what's the best way to contact you and find out more?
So if you have a look on our website, which is fishersmith.co.uk, then you'll find contact us forms, you'll find our Twitter and LinkedIn profiles on there, and it's fairly easy to find me and connect that way.
Well, very good. Iain, I think it's really cool what you're doing. I see your vision, pun intended, and I think it's great stuff. So I appreciate you coming on the podcast.
No, thank you for having me, Richard.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.